Hey guys, sorry for the late video. We had kind of a crisis happen today with some friends. So we've been kind of dealing with that throughout the day. We're going to talk about a different way to solve quadratic functions, and it's called completing the square. So when you see this on YouTube, it's just going to be called completing the square. Okay, now I got to be honest with you, this is not the most efficient way of solving a quadratic function, but it'll work. But we're going to use it to share with you how the quadratic formula was created or derived. All right, so what on earth do I mean by completing the square? Okay, it smells like somebody's burning toast. I know you can't smell that, but I can smell that. So when you are completing the square, you're going to transform. So transforming a squared plus bx into a perfect square trinomial. Okay, so I'm going to give you a demonstration of how it works, and we're going to practice it with something that looks like this. Y equals x squared plus 6x. 6 looks like b. There we go. 6x plus 7. So here's your steps to complete the square. So again, it's a function, it's an equation, it can be an expression. I did see some people do this on their homework and before we ever talked about it, and again, I think it's a really inefficient way because it takes so long to do. But, you know, it's just another thing. So what we're going to do is we're going to take the linear coefficient, so remember, the linear coefficient is going to be the term in front of the x. Okay, we're going to divide the linear coefficient, that b, by 2. Means we're going to cut it in half. So we're going to have b over 2. And then we're going to square the result. So in other words, we're going to take that b over 2, and then we're going to square it. So now we've created a perfect square. So to create a perfect square trinomial, we're now going to take that value and add it to the expression. So add this value, and I'm talking about what we got in step 3, to the expression. We have the ax squared plus bx, and then we're going to add, I'm just going to make it one big solid color, that quantity b over 2 squared. Okay? Now, we can do this with an expression, and we can also do it with an equation. So if this is part of an equation, we're going to add that b over 2 squared to both sides of the equation. So remember, we got to keep that equation balanced. To do that, whatever we do on the left of the equal sign, we're going to do on the right. Okay? So we're going to solve some examples. I'm going to go on to the next page for that. So the first problems we're going to solve, first couple say, complete the square. We're going to find the value of c that makes the trinomial a perfect, oops, I went too far, trinomial a perfect square, or a perfect square, trinomial. Okay, so we're going to do two of those. So you're going to see something that looks like this. And our job is to figure out what would C be so that my trinomial is a perfect square trinomial. So remember what it said. Our focus is on the linear coefficient. We're going to cut it in half. And that's going to equal 2. And then we said we're going to square it. And that equals 4. So if I add 4, then I have a perfect square trinomial. So I would have x squared plus 4x plus 4. Okay. Now, I can factor that, right? And I can show you it is a perfect square trinomial because I can take the square root of the first term. I can take the square root of the second term. If I multiply them and double them, I get 4x, which matches, and of course we had a plus here. So I'm going to take these two square roots, take the sign of the middle term, the linear term, and that's what I would get if I factored. Okay, let's do another one like that. R squared minus 8r plus c. So again, I'm going to focus in on the linear coefficient. I'm going to take it, I'm going to cut it in half, and I get 4. And then I'm going to square that, because I need it, oops, sorry, what's the plus doing there? Equals 16. So what I would have to make it a trinomial square is r squared minus 8r plus 16. So again, I can prove it's a trinomial square. I can take the square root of r squared as r. I can take the square root of 16 as 4. The constant is positive. If I take those two terms, multiply them, and double them, do I get the middle term? And the answer is yes. So if I factored this, I take those two terms, r and 4, and then I take the sign of the linear term, minus, and that's what I would get. I get the same binomial twice. Okay? So now we're going to go ahead and solve equations. So I'm going to go to the next page, and we're going to change direction. So this should be your second page. So we're going to say lesson 9.4. I'm just going to call it completing the square. I don't know why I wrote such a big title the first time. Oh well. So these directions say solve by completing the square. So honestly, I would rarely use this strategy. However, I would, try to play the game. If I couldn't play the game, then I'd just go into quadratic formula. That's basically it. Unless I saw there was a difference of squares or trinomial square, right? So we're trying to create that trinomial square. All right, so first, let's see, number 3, solve by completing the square. You've got x squared minus 6x plus 9 equals 7. Okay, so remember how we start. We have a quadratic term and a linear term. That's what we started with when you saw it. So what I want to do is recreate that situation. So I'm going to take the, oh no, I did that wrong. It's, sorry, I wrote down the wrong number. I was like, wait a second, that doesn't make sense. Try that again. So it's x squared plus, or minus 6x plus 12 is equal to 19. So we want to get the quadratic and linear term by themselves, so I'm going to subtract 12 from both sides. All that I'm going to have on the left is the quadratic term and the linear term, and it's going to equal a constant on the right side. So I have a blank there because I want to be able to complete the square. So I go ahead and I grab the linear coefficient. I cut it in half. And then I square that because I need to create that perfect square. So what I'm going to do is I'm going to add it in 2 locations. Okay, so now what I've done is I have gone ahead and I've created a trinomial square on the left. So if I factor it, I get x minus 3. Now, do you note that quantity squared? Do you see someplace where the 3 showed up? Do you see it? Yeah, when I take that linear coefficient and cut it in half, the number I get is the number I'll get when I factor my trinomial square. Pretty cool, huh? And then on the other side, that equals 14. So now that I have a square, I can take the square root. But because I'm taking the square root of a variable, I need to write plus or minus on the other side. Did I do? Yeah. Oh my gosh. I think I'm working too late because I just made like the dopiest mistake ever. I can't even subtract right now, guys. Alright, let's try this again, shall we? 19 take away 12 is 7. Okay. When I add 7 and 9, I get 16. There we go. Ay, 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 ay. So the square root of a quantity squared is the quantity. Equals plus or minus, and the square root of 16 is 4. So then I add 3 to both sides, and I have x equals 3 plus or minus 4. But because those are numbers, I need to solve the 2 cases. So the positive case is 3 plus 4 for x, and the negative case would be x equals 3 minus 4. So I get x equals 7, and x equals negative 1. So the solution set contains 7 and negative 1. All right, let's try another one, and let's hope I don't mess it up like a... Pooh! So I got 2x squared plus 8x minus 18 equals 0. Now, one of the things that has to be true when I'm doing these types of problems is that my a value cannot, must equal 1. So a must equal 1. All right? If the a doesn't equal 1, then I cannot do completing the square. Okay? Just telling you. So the problem is sometimes I'm going to create some fractions. Okay? So you're going to divide everything by the quadratic coefficient. Okay, so that's going to look like negative 2x squared plus 8x minus 18 equals 0. And we're going to go ahead and divide everything by negative 2. So that gives me x squared minus 4x plus 9 equals 0. Okay? So then we're going to go ahead and get the constant over to the other side. So all I'm left with is the quadratic term and the linear term. And then I'm going to go ahead and take my linear coefficient, and I'm going to cut them in half, which equals 2. I'm going to square 2, which equals 4. And I'm going to add 4 to both sides of the equation. So that gives me x squared minus 4x plus 4 equals negative 9 plus 4. So then I can factor the left side. We have x minus, because the linear coefficient is negative, 2, because that's what I get when I take the linear coefficient and cut it in half. So if I take the square root of 4, I get 2. And over here I get negative 5. So then I'm going to take the square root of both sides. Got to put plus or minus. And then we run into a little snag. And that's that guy. And we can't take the square root of a negative. So this is an answer where we actually get no solution in the real number system. Okay, so what that means is that you're going to learn in Algebra 2 trig, that we can find solutions to this problem, but it's in what's called the imaginary system. So we have a real number system and we have an imaginary number system. Now the one thing you haven't seen yet, and I want to introduce you to it, is I've always had even linear terms. So what if I don't have a linear term that's even? Let's do one of those. And then we'll save the voila to the last. So we've got x squared minus 11x plus 3. Well, that's the weirdest x I think I've drawn in a long time. Plus 3 equals 5. So first and foremost, we need to get the constants together on the right. We have x squared minus 11x equals 2. Then we're going to take the linear coefficient, which is an 11 this time, and we're going to cut it in half. Now, because it's a fraction, I'm not going to change it to a mixed number, because remember, I need to take that guy, and I need to square him. So I'm going to take that 11 halves, and I'm going to square him, which is 121 fourths. That's what I'm going to add to both sides. So now we end up having fractions to contend with, and I know what you're all thinking. Lovely. Now, in order to add 121 fourths to 2, 2 has to get a denominator of 4. Otherwise, I can't add fractions unless their denominators match. So I'm going to change 2 into 8 fourths. Okay? I can factor the left side. So I have x minus, and then we take that 11 halves, the square root of 121 fourths. That quantity would be squared. Now on the other side, I'm going to get 129 fourths. Now we can take the square root of both sides, but remember, because I put a square root over a variable, I have to write plus or minus on the other side. So I get the square root of a quantity squared is the quantity, so x minus 11 halves equals plus or minus. Now remember what we're going to do here. We're going to take the square root of 129 over the square root of 4. Well, I can't take the square root of 129, so it just stays as the square root of 129, but the square root of 4 is 2. Then I need to get the x alone by adding 11 halves to both sides. Now, that plus minus sign should go in the middle, so I'm going to get 11 plus or minus the square root of 129 over the common denominator of 2. And I can leave the answer just like that. I can also convert this to a decimal answer if I take the square root of 129 and I add it to 11 and I subtract it from 11 and divide each of those answers by 2. So I can go further if I want to, but I think for our purposes, I'm just going to go ahead and stay right here. This is actually the exact answer. When I do the square root, I am now estimating. All right, here comes the biggie. You guys ready for this? We're going to do what's called deriving the quadratic formula. And to do it, we're going to use completing the square. Oh, that's an interesting way to spell that. So we're going to start with ax squared plus bx plus c equals 0. So just like we said before, we're going to isolate the quadratic and linear terms by getting rid of the coefficient, taking it to the other side by doing inverse operations. So now I have ax squared plus bx equals negative c. Okay, so remember what we do. We take the linear coefficient, we're going to cut it in half, and that's going to equal b over 2, and then we have to square that guy, and that's going to equal b squared over 4, and that's what we're going to add to both sides. So that gives me ax squared plus bx plus b squared over 4 equals, and don't like looking at that minus first, I'm going to put the b squared over 4 minus c. But I cannot combine those two numbers because they don't have a common denominator. So if I want this c to have a denominator of 4, I have to multiply the denominator by 4, and I have to multiply the numerator by 4. So the left side is now a perfect square, and we've got, sorry, I don't need, oh, I messed up. Oh my gosh, I should be going to bed. I forgot a crucial step. Do you remember what it was? I can hear some of you say, Rosner, you forgot something. In fact, I can hear Samson say this. Let's try this again. So we're at ax squared plus bx equals negative c. But we forgot, no, I forgot that my quadratic coefficient has to equal 1. So I divide everything by a, and that gives me x squared plus b over ax equals negative c over a. Ugh. Honestly, it's been a day. It's been a day. So I'm going to take this guy, b over a, and I'm going to cut him in half. But to show that, I'm going to do it this way. That's going to give me b over 2a. This is starting to ring any bells? But that's not all we do. We take that guy and we square him. And that gives me b squared over 4a squared. That's what gets added to both sides. Now this is starting to make more sense. So I get x squared plus b over ax plus b squared over 4a squared equals, again, I don't like that minus first, so I'm going to go b squared over 4a squared minus c over a. Now, we do have the problem again, like I had mentioned before, that I have to have a common denominator in order to add or subtract. So we're going to multiply top and bottom by 4a. Now, left side can go ahead and get factored, and it's going to be x and then plus, because it's a positive linear term, and we're going to have the square root of b squared over 4a squared is going to be b over 2a. The same thing we got when we took half of the linear term, okay? And that quantity is squared, and then over here we're going to get b squared minus 4ac all over 4a squared. Okay, now I can take the square root of both sides. And remember, this is the same thing as saying plus or minus the square root of b squared minus 4ac. Is that starting to make sense? Divided by the square root of 4a squared. Okay, so the square root of the quantity squared is the quantity. So we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over square root of 4 is 2, square root of a squared is a. Last but not least, I need to subtract b over 2a from both sides. Those guys have the same denominator, so I get negative b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula. It's like a signature. All right, there you go, guys. Enjoy. See you tomorrow. Bye.